Okay, it's been requested that we work on naming compounds today. Okay, so with that being said, we'll start it off perhaps just a little simpler than what you're going to encounter is what I'm trying to say. Okay, now for one aspect, okay, the periodic table would tell you the answer to this. Okay, why is there 2 here? Okay, and we always say go by your negative charge first, and this is a halogen. It's in what column? With the rest of the halogens, in column 7. That means it's got a negative what charge? Okay, then again, your periodic table will tell you, even though this is a D block element, what charge does zinc have? Okay. So that does not add up to 0. So then what's your least common multiple?
2.
Okay. What's 2 divided by 1? 2. That's where that number comes from. What's 2 divided by 2?
1.
And that's why it's just understood that we've got a 1 there. So Zn stands for what? Do we need to do this because it's in the D block? Well, I suppose if you say that often enough, yes or no, one's going to be right, one's going to be wrong. No. Then we don't need the parentheses. That's right. Okay. I mean, it's not wrong if you do that. It's just makes me think, did we really do that bad of a job teaching you this content? That's what would maybe resonate. Okay, so then what is Cl standing for? I heard someone say chlorine. Is that right? Okay. So again, we said we'd start off just a little simpler than normal. Let's go ahead and...
You wouldn't write zinc chloride 2, or how would you know that there's 2 chloride?
You don't need to.
For this?
Yeah. Or just when you balance it, you just...
Okay, have we ever put anything behind these? No, and we're not going to start now either. Okay, so moving forward then. All right. A D D D D D D D D D D D D.
That's what we just said, Tom.
Yeah!
What we just said, what?
He's being an idiot about the Oreos. It doesn't matter.
Oh. Well, and we've done this before. We do have a simple fix for that. I mean, real simple. And that fix is what? None.
We were saving it for our ice cream.
Okay, well, that's... We're not I'm not a century, okay? What is a century besides 100 years?
Fun hater? I don't know.
No? A fun hater?
Yeah, I don't know.
A century is one who stands guard, okay? All right, besides 100 years. Okay, so let's go with a separate D block element, one that has multiple charges to it. Okay, let's pick one that would be something that we'd probably use in the 3D block. I mean, it doesn't have to be out of there, but you could use tin, you could use antimony, you could use lead, you could use mercury, okay? Okay, so with that, okay, iron. Okay, what type of iron? And why would it be Why would we be asking what type of iron? Okay, so we said 2. So how do we know we're referring to iron 2?
You put the parentheses.
Okay, and then you said oxygen? Okay, so if that exists, how about, and we've done this before, I know we have, because I wouldn't expect you to remember this, but someone might. What's the symbol for iron? What is the symbol for the oxide ion? Okay? Yeah, and again, I'm sure, and again, it's just human nature, and you can laugh. We're still going to see this. We're still going to have people do that. Okay? Why would people choose to do that?
Because there's a 2 after iron.
Okay?
But it's actually the charge.
So, if it is the charge, which it is, okay, -2, +2. Does that add up to 0?
Yeah.
Do we need to change anything in there?
No.
No, we do not. Okay? So, how is iron 3 oxide different than iron 2 oxide?
You would have to change it.
Okay, everything's still the same. It's still Fe, and it's still O. Go by the charge of your negative ions. So this is still -2. Iron is plus what in this case? That does not add up to 0. So what is your least common multiple?
6.
What is 6 divided by 2?
3.
Okay. What is 6 divided by 3?
Quit copying me.
Okay. So this is something that you see every day. You just don't realize, or unless it's pointed out to you, that this is a component of this. Okay? Does anyone know what hemoglobin is?
No, but I
Never heard of it.
sounds like isn't it like sounds like something a leprechaun would hear. Isn't it like a type of food or something in your body?
It is something in your body.
But I don't know like what. It's something
Blood.
it's in your heart.
Is it in your muscle?
It's flowing through here.
Blood.
Yeah. Hemoglobin is a component of blood. Okay? Yes, there's hemoglobin in your veins too. Okay? It's the amount of hemoglobin that will either look like that.
Will we have to know what hemoglobin is?
No. That's biology.
Why would we write that twice? And why is one red, one is blue?
Your white blood cells and your red blood cells.
You might think so. The amount of hemoglobin, if the oxygen content is high, it is red. If the oxygen content is low, it's going, not that it's going to appear blue, but it's going to be inside of veins, and no, it's not blue blood.
Is that why you turn purple?
No. Okay. So with that, it's just the amount of hemoglobin or oxygen that determines the shade of red. So when you say holding your breath and turning purple, that has something to do with that, is the amount of hemoglobin in there. That is correct. Okay, so a common name for this is hemoglobin. What might be the common name for this? Is something that you see every day, especially on pickup trucks around the wheel wells.
Rubber.
Okay. When iron oxidizes, okay? In other words, there's moisture in the air and the oxygen in the air combines and attacks that iron and causes it to decompose and or rust. Okay. Okay. List the polyatomic ions, the names of them.
Oxygen.
No, that's monoatomic, and that's oxide.
Phosphate.
Chloride. Oh,
Hydroxide.
oh, these ones.
Sulfate.
Sean actually wants cookies so bad. Ammonia.
Yeah, ammonium.
I don't know anymore. I'm lost.
I almost said non-name.
Carbonate.
Carbon dioxide.
And then, let's see here. There's one more. Okay. And this is one of those aspects you just settle in and think, okay, I'm always going to have this given to me. I'm always going to have this given to me. Okay? That'd be a bad choice to go down. Use what you see as a guide to tell you what the formula is. What does this tell you? It must have what element in it? Okay? And it also has something in common with this, with that, and with Nate here. Okay? No, so we wouldn't put that around here because we don't want you to do that either. You probably do that enough anyway in this class. Okay? Because we don't like science. I don't know, maybe, maybe not. Okay. So, what element does sulfate have in it?
Sulfur.
What element does carbonate have in it? What does nitrate have in it? Okay, we'll come back to this one. Okay? Now, these all have something in common. The ATE is referring to the other element.
Oxygen.
Okay? And it's the different ratios that we would see. Okay? So, how many oxygens does the phosphate ion have? No. How many does the sulfate ion have? No. No. No.
4.
How many does the carbonate ion have?
4.
And what about the nitrate?
2.
No.
3.
Okay? So we said we'd come back to this one. This one's separate than pretty much the rest of these. We'll come back to that one too. What's significant about ammonium? NH4 with a positive 1 charge. What about hydroxide? OH with a negative 1 charge. Okay? Yes, what? Don't we got it now, don't we?
I know, but like, so for during the test.
Well, didn't we just say we'll always use that as a crutch then? Oh, we're always going to have that given to us. We can rely on that. We're going to our next football game, volleyball game. Oh yeah, we got a head start. We can rely on that. We're going to start out. It's 14-0. We're ahead. Kickoff's ready to begin. Oh, we're up 1-0 in volleyball because we're going to rely on that. We already have a 3-run lead, and no one's been at bat yet.
Can I or not?
We'll have these up here. Okay. And I do see some of you writing it down, but it's probably not going to help you. Well, it's going to help you out now, but we want you to be able to remember and utilize this. Yes, I understand that. Is it really difficult to associate all of these? Okay.
4, I don't remember like the whole. Well, that wouldn't be very hard to figure out. I just don't remember the.
This one is the only one with what type of charge?
Plus negative 3.
No. -1. What does sulfate have for a charge? Carbonate. Nitrate.
One.
See? Why are you saying you know what it is? Why do you think you need to write it down?
I don't know.
Oh, because I want to have a 14-point lead before kickoff. That's the only way we're going to win. We can't win unless we have a head start.
No, it's not that we wouldn't win. It's just that I'd rather have that.
I want to have a better chance at.
Yeah, but chance.
Well, you have that opportunity between now, you have Thursday, you have Friday, you have Monday, and Tuesday, because, right. And this doesn't pertain to everybody. I would certainly be led to believe that in band and or chorus, you have to memorize your music, right? Okay. If you are in a stage show, you have to memorize your lines. You can't say, well, I just want to carry the book with me all the time. I can't do this. Is that right? You can't do it? Memorize your lines? Okay. So how's that different than this?
Because that is like an order. It's a conversation.
Okay.
Well, like I'm writing them down so I can study them and like look over them rather than just like them being handed to me for the test, but I'm gonna be able to.
Well, it depends where you are writing it down. Maybe I didn't clarify that enough. I would not write them on your periodic table. Write them on a scratch sheet of paper then, if you need to do that. Yes, you can use your periodic table. Right. I guess, see, how difficult of a concept was it to make that correlation? Not very hard. Did anyone else think that correlation was difficult? Okay, well, either we don't want to raise our hand or we agree. I don't know. But. Okay. Because typically what we do is, excuse me, we'll give you this content. I was going to say count, but content, okay? But since this has phosphorus in it, you should know that that's phosphate, right? Yep. That's why we underline these. Or I guess didn't underline all of them, but if you see NO3, we certainly should know that that's nitrate because it has nitrogen in it. Okay? There's going to be times where you are responsible for having to, per se, correlate material or memorize it or something to that effect. Okay. Can I/we erase this? Yes. Okay. So, a monoatomic ion with a negative polyatomic ion. So what does monoatomic mean, first of all? No. Oh, I suppose you could say that, yes. But there's a better example we can come up with. That we know the charge, that we would not need to look at Roman numerals for that. That's what I meant by monoatomic. Yes, yes. What is an element on that table that you would, why are you right? It only has one type of charge, okay? So.
Albert Newton, like I said, bro, it's just.
Albert Newton?
I'm a genius, bro.
Okay, we want a negative polyatomic ion now?
Phosphate.
Okay? Okay. So, what is the symbol for magnesium? What is the formula for the phosphate ion? You know that it has to have that element in it. And you know that when it has that suffix, there has to be oxygen in it. Okay? And then, what does the phosphate ion have for a charge?
Negative 30.
What does magnesium have for a charge? Okay? That does not add up to 0. So what do we do to get this to add up to 0? How did you, you're right, but how did you know that? Who does not know how to get this compound to balance out? Okay? What is the least common multiple between these? What is 6 divided by 3? 6 divided by 2? Okay? Been doing that for quite a while, right? I mean, not recently, but probably for the better part of, I would say, late February into middle of March or end of March, because then by the time the end of March rolled around, we started balancing chemical reactions, which this was still part of that content, because you might be, let's say, reacting magnesium phosphate with a separate compound or a separate element in a single replacement reaction. So it's something that we never really forgot, because we continually reinforce this material. Okay, now we want we're requesting another separate negative polyatomic ion and a separate positive ion that has multiple charges. Well, we could do ammonium too. Okay, we'll do both of them. Okay, so you had said, we'll come back to that example, you had said ammonium, right? Okay, so ammonium, okay, so a monoatomic negative ion or a polyatomic negative ion?
Sulfate.
Okay, so what is the formula for ammonium?
NH4. Positive 1.
This has to have what element in it? How many oxygens?
4.
What's the charge of sulfate? Okay, that does not add up to 0. What needs 2?
2 ammonium.
Okay, what is 2 divided by 1?
2.
What is 2 divided by 2?
1.
And we've got 1 sulfate. Yes? Okay. Then can we close the books on this?
Yeah.
Okay. All right. And then get back to a positive ion that has multiple charges. Calcium only has 1 charge.
Carbon.
We've done iron already. Carbon, nope, that's part of the formula. We did zinc already. That only has 1 charge. That's a monoatomic. Okay, tin. All right. What type of tin?
Plus 3.
No.
Oh, never mind. Plus 4.
Okay. That is the Roman numeral. Why are we putting the Roman numeral 4 inside parentheses? Okay. So then, do you want a monoatomic negative ion or a polyatomic negative ion? Okay, what is your monoatomic ion?
That's why I want to know it.
Bromine.
Okay.
I probably do know it.
A negative ion that only has one charge and it's only one atom or element.
Could be hydroxide.
Nope, that's a polyatomic ion. Nope, not carbon. Okay? But we're not going to write bromine, we're going to write what?
Bromide.
Okay? So, what is the symbol for tin?
SN.
What is the symbol for the bromide ion? Okay? Go by your negative ions. Bromine or bromide has a charge of negative what?
1.
Tin has a charge of what?
4.
Okay? It can be +2 or +4, but this is telling us it's +4.
Can you use 10 as a negative 1 too?
No.
Or negative
Well,
4,
not for
I mean?
our purposes. And it might say that on there, but I would be led to believe that just like on this table, the elements or charges that are listed first are its most common ones. And we only do the most common charges. We would never use a -4 for this. And I don't even know if Bob over here would say that tin can have a -4 charge. I'm going to go with no. And maybe it says it on there. I don't know.
Why is it Bob?
See the name on it?
Yes.
Why?
Students years ago didn't like saying periodic table all the time. Could we just call it Bob? I said, all right. So when we say Bob, we're talking about the table. Does it say -4 on your table?
Should we cross that out?
No.
You don't have to cross it out because we would never use it. Okay? Kind of like the little red button in the Oval Office.
Don't press.
Little red button, you press it, might release some nuclear weapons. Yes? Yes. Okay. Does this add up to 0? No. What is the least common multiple between 1 and 4? Okay. So, what is 4 divided by 1?
1,
What is 4 divided by 1?
4,
What is 4 divided by 4?
1.
Okay? Do we understand that the answer that you get when you do these is what you put below, correct? Okay? Do we still like seeing this? Does that help? Keep doing that if you need to. That's telling you what you're doing. Now, if we're watching this later, yes, I understand. There's a glare here, but past students have said, we've made it, we persevered, and we were okay. So I would presume that the rest of you can do okay as well. Yes, yes. Anything else? More naming compounds?
Do you want to start diagrams or?
This is your time. We're on your time.
Sure, let's do some dot diagrams.
Dot diagrams has been requested. Okay, can we erase this? I might have to get rid of that marker. It doesn't erase very well. Okay, if you had your pick, which would you prefer doing? An ionic compound or a covalent compound? Ionic is probably better. Why might that be?
Metal, non-metal.
Metal and nonmetal. Okay? That means it's a complete transfer of its outer energy level electrons. So,
Is metal on metal or non-metal or?
Non-metal, non-metal.
2 nonmetals is a covalent bond.
What is 2 metals?
Metallic bond. We don't do metallic bonds. We could, but we want to draw the line somewhere. Okay. So let's go ahead and we'll just keep it really, really simple. An alkaline earth metal. In other words, column. Okay. So what is an element out of column 1?
Iodine. Lithium.
Potassium.
Okay. So let's have a halogen now.
Bromine. Oh my gosh.
Okay, so for lithium bromide, if we're going to do the dot diagram for this, okay, how many valence electrons does bromine have? Okay, and the reason it has 7 is why? It's in the 7th column. Okay, lithium is in what column? And that's no lie. Right? No lie. Right? That's no lie. Yeah. Right. All right. So, what about lithium oxide? Okay. What column is oxygen in?
So we need 2 lithiums.
We'll give you that much. How do we finish that?
You put one on this side,
Okay. Put one on this side.
and then one on the other side.
Okay.
And then you put a lithium on both sides. And then you put 1x on top, or a triangle, and then you do the same thing on the other side.
Put on the bottom this time.
But on the bottom.
Got Eli this time. Okay.
What would you do if, say it was lithium, oxygen, oxide?
Lithium oxide. We just did lithium oxide.
Oh, it has to be lithium too. I can just do lithium.
No, because you can have 7 for
Okay.
oxygen instead of 8.
Tom, it's okay.
-2, correct?
Yeah.
Plus 1. So we get the formula, 2 divided by 2, right?
Yeah.
Okay, 2 divided by 1 gives you 2. So you have 2 lithium ions, and then,
But can you do a dot diagram if you only have one lithium?
no, that would not, that's not stable. Okay, so then this one would get to be a little tricky. Alkali metal now. If alkaline earth is 1, alkali metal must be what?
2.
Okay, so what's an alkali metal?
Radium.
I said that backwards. Alkali metal is column 1. Alkaline earth is column 2. So we want alkaline earth metal, magnesium. Okay, so then sulfide or oxide? Okay, so this is -2, that's +2, that adds up to 0. So we don't need to change anything. This is perhaps a little more tricky. Okay, so just like what we did here, okay, go ahead and this would be an acceptable way of doing that. Notice there's your 6 valence electrons for that of oxygen, but it's too short. Where does it get its final 2? From the magnesium.
One of its things.
So you could do this, okay? Because magnesium's got 2, I would suggest that you don't do this, because how would that be inaccurate?
That means you have two
Because it
magnesium.
made
You're saying that you got 2 magnesiums and you don't, okay? So that's probably the most common way to do it. I certainly wouldn't count this wrong if you would have decided to split these up, because technically it's not wrong, it's just probably confusing. So I'd say keep those 2 electrons together on the same side. We'll put that back to how we found it, and then that perhaps makes a little more sense. Okay? How do we know that, other than it's metals and nonmetals, and that's what we told you, these are ionic bonds, but how would you illustrate these being ionic bonds? How many electrons are around this oxygen? How many are around each lithium?
None.
Well, that's odd. Aren't we supposed to satisfy the octet rule?
No, because metals don't want.
Metals don't want electrons around. They want to get rid of them. And that's why we see oxygen having a box around it, but lithium does not, because it gave its electrons away to the oxygen. Same with the magnesium. Okay. We got time for one covalent bond. Can we erase this? Okay. Yes, sir. All right. How do you know you're looking at a covalent bond?
When it's two nonmetals.
If it's two nonmetals, and what are they doing more, about 95% of the time, what are they doing with their electrons?
Taking them
Sharing them. Okay? That gets to be a little more complex.
so it's a
This is the simplest covalent bond. Is that a stable bond? Yes, it is. Okay? This is an exception to the octet rule. Okay? So let's maybe do something like,
oxygen to oxygen.
we can.
Is that a super hard one? Or?
It can be.
No.
Sure.
No.
Okay, we'll come back to that then. Okay? Looks confusing, don't it? So, just show you the right way to do it, or show you the process that you might take this. Okay. Right way. Okay.
Why you don't want to know how to do it? You just want to memorize the right answer for it.
No, he's gonna show us the right way to do
Or
it.
you said the right answer.
No, I said right way. I don't want to get confused.
Okay. What column? You would start with carbon, because that's what you're going to want to start with. If that's not present, then you probably want to start with nitrogen. Then if that's not present, well then you'd probably want to start with the lowest number of atoms within a formula. And notice these all have 2 in them anyway. Okay, so what can carbon do that many other elements cannot do? It can triple bond. Do we want to do a triple bond?
No.
What did we say? You were right when you said triple bond, but should we just throw a triple bond in there? No. I would agree.
Do double bond?
No, when we see these, has nothing to do with charges. It's already balanced out.
It can bond to itself.
It can bond to itself. Okay? So let's go ahead and put an electron there. And what are you illustrating when you put 2 of the same electrons from the same element on top of one another? You're going to illustrate a double bond. Okay? So there's one carbon. And what column is it in? So that means how many more electrons are left? Do you want top and bottom or top and side? Okay? So then there's one carbon atom. Here's the next carbon atom. You're doing the exact same thing as that. Okay? So you're illustrating a double bond. That's what we mean by these equal signs. So then, okay? So that does it for our carbon atoms. Now what?
Bromine.
Okay? Where can you put a bromine?
Has a negative 1 charge.
On
so
the
you could
top.
just put it
Charges
on
have
top.
nothing to do with it.
That has 7.
Or, oh my
So
god.
you could put it on top of them.
Okay? And don't do this. Don't stack them on top of one another. Okay? Because you're making a single bond here. Okay? What do you suppose you would do with this X?
Maybe another
That
bromine.
would be chlorine.
You can do chlorine or you can do bromine, doesn't matter.
Should we put the other bromine over here?
You can. You tell me. Which do you,
Yeah,
Put the other bromine on top of the carbon.
Yeah.
this one?
Yeah.
Okay.
If we put it on
Why don't
top of
we,
it, is it gonna be a double bond? I don't know.
why don't we do this then? Okay.
Create a double bond though right there, the bromine.
It looks like it is, but they should be far enough away. Because bromine can't double bond.
Oh, and then
And besides, well, yeah.
Space them out more, but
Yeah, that's why it's in a different color.
One of
put a
the,
chlorine on the
what
side.
if one of the carbons had the bromide on the bottom of it?
Yeah, but if we
do the
split
same
them.
thing.
If
What,
we
over
know-
here?
If we know, like, it's not gonna double bond, then it'll be fine.
Right,
Just
right. Okay, so that must mean we can put a bond here, which we can.
chlorine.
Chlorine
And
has
it's
a
also in the seventh column.
So what are we going to put over here now? Yeah, you can see it on there. It's not very dark, but we get the idea. Okay, so this chlorine has how many electrons around it? Okay, what about this bromine? There, and this one. Does this one have 8 around it?
Yes.
Well, not around it, but it has a double bond.
It has eight.
Okay, so don't put a box around, you don't put it around 2 elements, you put it only around 1, and you don't have to do this, it just helps you see 2, 4, 6, and 8, because these are being shared. Then you can do the same thing here if you chose to, you don't have to. 2, 4, 6, and 8, so that's got to be right. And what we would do for an organic compound is exactly what we've done below. These mean the exact same thing. But we wouldn't name that, because if you did, that would be, let's see here, 1, 2 dibromo dash 1, 2 dichloroethene. It's kind of a mouthful, isn't it? Okay.
Wait, can we do that instead of drawing all the things, or do you want us to like draw it out like you did?
You can do this, because these mean the exact same thing.
For like a dot diagram.
For a dot diagram, those mean the same thing. All right, we're running short on time, so we will catch up to you next time.